it says that ST plus TU equals SU. And you already know this. You already intuitively know that part plus part equals the whole. Does that make sense?
Mhm.
Okay. So if the whole thing is 22, and you know that this other part is 4, maybe call this X, your geometry problem turns into an algebra problem. Does that make sense?
Yeah.
So you have to be able to resolve a problem like this into an algebra problem that you can then solve. You subtract 4 from both sides, and maybe you already know the answer is 18 by looking at it, but you are expected to be able to solve some problems like this. Okay. And you might say, well, I know how to do that. That's not hard. And you'd be right. This really isn't that hard. Where it gets more difficult, and one of the other types of problems you'll see in geometry is when you, the student, have to draw a picture. So it's really nice when the picture is there. It's kind of like, me asking for something you're working on in your book. It's a lot harder when it's like, what's going on here? So you you want to, and you would know this ahead of time, but this problem right here is something like this. Here's A, here's C, and B is somewhere. I don't know where B is. I'm just going to put it in the middle. It doesn't matter where it goes. A B is 8x plus 5. B to C is 5x minus 9. And the whole thing is 74. Is that okay? What we've done clear?
Yeah.
All right. So segment addition property says that AB plus BC equals AC. Piece plus piece equals the whole.
Okay.
Right? So what is AB represented by in this problem?
8x plus 5.
8x plus 5. And what is BC represented by in this problem?
5x minus 9.
Okay. And so the whole thing is 74. So this is an equation that we have learned how to solve. You solved a bunch of these. Will you give this a try and solve for X, please?
Okay.
How are you doing on this one?
Still trying to figure it out, but I'm having a little trouble actually.
Okay, so we're going to combine like terms, 8x and 5x. What does that become?
13x
13x. Then we get 5 and minus 9. What does that become?
minus 4.
Okay. Now we talked about the idea that you undo addition and subtraction before multiplication and division. So add 4 to both sides. And then how do you undo this 13?
Division.
Division. Divide both sides by 13. Can you tell me the value of x here?
Um, Six or
6. Yeah.
yeah.
And again, you're welcome to use a calculator with me. I mean, I'm not going to, I mean, it doesn't matter to me. It's for the calculation. So, okay, really important here. Really, really, really important here. And I didn't put this in here, but sometimes these problems just say to solve for x. Have you done that? Yeah. Yeah, there's my x value. Yay. Okay. Sometimes they don't. Sometimes they say for like AB or BC. So you should be prepared as a student, not only to solve for x, but put x back into the problem. All right. So here we go. I want you to put x into each of these and give me the lengths of AB and BC, please. Is it clear what I'm asking you to do?
I think so.
Okay.
So like for AB, would the answer be 8 and 5/8?
And well, so you're putting 6 in for x, right? Right. We got 6, it goes in for x, and you're multiplying. So 8 times 6 plus 5.
Oh, okay. AB's 53 and
Okay. So
B, oh, sorry.
yeah, BC, go ahead and calculate BC. There's a couple of ways to do it though. You can, and what I'd like you to do is do it this way where you put the the number in for X, but because you know that 53 plus something adds up to 74, you already will know the answer.
Mm-hmm. So BC's is 21.
So the point of all this is you get a problem like the one that I'm giving you here, and it could ask for anything. It could ask for X, it could ask for AB, it could ask for BC. In some other problems, it will ask for the whole thing. You almost always solve for X, but what you don't know is whether you are done or not. Okay. All right. So we're gonna look at another problem. We'll kind of set it up together. You can work through it here as well. You do want to draw a picture. Okay. You kind of match, say, okay, A goes to B and B goes to C. So we know that it's A, A to B is somewhere. We don't know where, it doesn't matter. And there's C. So we know that AB is 13 plus 2X, BC is 12, and the whole thing is X plus 32. And I really do like the idea that you write it out this way. Um, I think that's really important to be able to solve some of these equations.
Okay.
All right, so now it's just like before. It's that AB plus BC equals AC. Part plus part equals whole. So instead of AB, use the variable expression for that 13 plus 2X. BC is 12, X plus 32. So this is kind of like the previous one. Will you attempt to solve this for us, please, for X?
Mhm. I got X equals -5.
Okay, you got X equals -5. do not think that that is the right answer here, just because, not because it's negative, but because I just quickly doing some calculations. It doesn't seem like that works out. Did you combine 13 and 12 to 25?
Yeah,
Okay, now we talked about this idea that you move the smaller x to the larger. So you subtract one x from both sides. Did you do this or did you do something else?
I didn't do that.
Did you move the 2x over to the right?
No, I uh subtracted 25 from both
Okay, so that's
sides.
okay. That's okay. Let's do it your way because you're going to see that this still works. What is 20 32 minus 25
7.
plus 7? Yeah. Okay. So uh the next thing here is to subtract one x from both sides. And you get down to x equals 7, like that.
Okay. I subtracted 7 instead.
Yes, and that got you to like you can't combine these like they're not like terms. Number has to go with number, variable has to go with variable like that. Right. So now that you got x, I'm gonna go back, grab, oops. I'm gonna go back here and I'm gonna grab this. What I want, and this is typically how the problems go. Now that you have x, I really want the length of AB. You know that BC is 12, and then I want the whole length AC. So you got to take that 7 and put it back in for X, like that.
So AB would be 27 and AC would be 39.
Okay. And sometimes just they'd say, sanity check or reasonableness check, like does 27 plus 12 equal 39? And it does. All right. And the reason you do that is just to make sure that, it's um it's there. Any questions, thoughts on that?
And no.
Okay. All right, let's have you try another problem on your own here, start to finish, and then we'll move on to something else. Um, it's really similar to what we've been doing. It's just they lay this one out a lot better. Um, they give you A to B, 2x minus 8. B to C is x plus 17. They give you the whole length. So you have to write the equation like we've been doing. You have to solve the equation, which is what we've been doing. That'll get you the x value. Then you put the x value back in to find these two. So I'm just standing by here. If you have questions, please ask. But this is the type of problem you absolutely can do on your own. And we'll talk about some angles next if you get this all correct.
No. I got x equals 10.
Okay. Um, how do you feel about your answer? Any questions
Um,
about solving it?
no.
I'm not saying you're wrong. I'm just asking. You can see here that you are correct. Good. Okay, so will you find A, B, and B, C for me, please?
Mhm. So AB equals 12 and BC equals 27.
Excellent. So I think you got the idea here. Next thing is is angles. So are there any angles that you remember from class or anything you guys have talked about in regards to angles?
Um, I mean, I don't really know. Like,
Okay. Do you remember what a right angle is, maybe?
yeah, it's 90 degrees, right?
Good. Good. And let's say two angles are complementary. Complementary. Do you know what they add up to?
No, I don't remember.
90 degrees. And then supplementary angles add up to 180 degrees. They are sometimes referred to as straight angle, or a linear pair. And this might seem like really overwhelming, but these are all definitions. Like you, as the math student, have to know right angle 90 degrees. Complementary means 90 degrees. Supplementary 180. Straight angle or linear pair 180. These both refer back to that right there.
Hmm.
All right. So just to kind of symmetry. I just need a moment here to grab some problems. These are awful. All right, give me just a moment. Okay. Here's a problem for us to look at. The problem will say something like we've talked about before. It might just say to solve for x. And the only thing you know is that the whole angle is a right angle. So this red box here means it's not a DVD rental. It means a right angle. All right. So what do these two angles add up to if this is a right angle?
90.
90s, right? So you have to know that. You have to look at a problem like this and be like, oh, they add up to 90. All right. So go ahead and try solving this here. It's another multi-step equation. Get the value of x. If you do find x, go ahead and put it back into each of these and let me know what you come up with.
Right. Okay, so x equals 18 uh and then it's 18 plus 16, which equals 34, and then 3x plus 2, which equals 56.
Okay. And your check here is that does 34 plus 56 equal 90? It sure does. Okay, so that's great. I'm glad. So you solve for X perfectly. You put it back in. Like it all has to work. You can't just it can't be like, oh, I solved it for X and then it didn't work. Like it's all got to work. It's kind of like a built-in check, if you will. Um, Now you guys are doing some angle bisecting stuff like with your compass and protractor, is that right?
Yeah.
I mean, any questions on how to bisect an angle?
No, our book kind of gives us directions on how to do them, the different kinds.
Yeah, I mean, you swing an arc, you swing an arc, swing an arc, and you do that there, get better. Um, have you guys talked about trisecting an angle?
Yeah.
Okay. So on a test or a quiz, like sometimes what they do is they don't like tell you this. They say like um construct a 30-degree angle, or maybe it's a 45-degree angle. And so you have to be careful, like to be like, well, how do I do that? So the 45 is the easier one. That's okay. I've made, let me do it correctly here. You make a straight line with a ruler, you construct a perpendicular, and then you bisect it like that. That'll get you the 45 and 45. The 30 requires you to trisect an angle, which is more challenging. Right? You gotta do this, and then you get the 90. Um, you make your 90 degrees, and then you trisect it. Do that. Sometimes they're really challenging, and they make you do like a 120-degree angle, but really that is like this angle, the 90 plus the 30.
Hmm.
You know, you got to think of it as 90 plus 30, or same thing with like a 45 and a 90. Lots of things like that that could come up. Yeah, I don't know. That's where you got to get a feel for your teacher. If you know someone who's taken the class before, that's where it's good that you can, ask them like, hey, what did you guys see last time you did this? And then, get an idea of that. All right. So the other type of problem you'll see is it's something where you have a straight angle. So where you have a straight angle. So and I'll do it in red here. This is the straight angle. And straight angle is 180 degrees, which means that the two of these add up to 180 degrees, which means again, you're writing yet another equation. This time it equals 180. Doesn't say it, doesn't say straight. You're supposed to assume that, which is reasonable. And yeah, it does work out.
Hmm.
All right. So go ahead and solve this for us, please. Get the value of x.
All right. Alright, so x equals 50, 30 plus 50 is 80, and 2 times 50 is 100, and 100 plus 80 is 180.
And that's the kind of problem that you're maybe going to see in this course. I don't know, but you're doing a great job here with me as far as solving it. So sometimes these are word problems. Let me see if I can find one of those. Oh, um, if you're wondering what I'm doing, I just go out to the internet and look for stuff that's consistent with what we're trying to do here. See if I can find anything. Not really. So I'll just handwrite it. It might say in or it would say something like given angle uh, BAD uh, measure of angle BAX is 4x plus 1, comma, measure of angle um, x, x sorry, I'm struggling here. B XAD is 9 at 9 plus x. Uh, and uh, these two angles are complementary. Sorry, this isn't written well because I'm just thinking about it right now. But what is the value of x? Would be maybe the first thing it would ask for. All right. So again, if there's no picture, you should draw a picture. And you'll notice this geometry. They use three-letter words. They use bat or dog or I know there's not that many three-letter words out there, but there's enough that they come up with some good ones. So B A D like that, and then they're saying BAX. There's X. They're saying, that's 4x plus 1. And then XAD is 9 plus X. And we know that they're complementary, which means that they add up to 90. So you would be expected to construct the figure, write the equation. I'd like you, if you don't mind, to solve for X here. Make this the last problem we do today.
Alright. X equals 16.
Okay, so you got 5x plus 10 equals 90, 5x equals 80, x equals 16. Good. And then you put those back in. If you could put those back into the two equations, and let me know what you come up with.
So BAX is 65 and BAD would be, yeah, 25.
25, yeah. And you gotta be really careful here. Like if you're tired or you're just not paying attention, it's really easy to like use the wrong number because they add up to 90. And 90 isn't 100, and 100 is like that good one that we like to add up to. It's really easy to kind of, you'll see on like a multiple choice test, like the answers like this. This is where it would throw you off a little bit. All right, we'll stop here for today. Good job. ahead and stop the recording.